Do you remember what we learned last time? We talked about the continuous random variables, right? So could you please give me examples of the continuous variables? Time. What kind of time? Things which you cannot count, okay, which you can measure, right? For example, I mean, we talk about the time, right, when your professor comes to the lectures, or time when the train comes to the station. Can you give me more examples without the time?
Water, yes, the amount of the water left when you sip water.
Okay. What? Height of the person, yes. Okay. So this is also continuous random variable, right? Because this is what you measure. You cannot count the height, right? You measure this. And this might be random for every person, right? And we need to learn about these distributions. So the last time we said that function which tells us about the distribution of the continuous random variables is called the density function, right? The density function. So it has a couple of properties. We say that we evaluate the probability of the x in some interval or in some set by integrating the density function from in this interval, right? So basically now the probability will be the area under this function. So previously in a discrete case, if I would like to find a probability or the sum of the probabilities, I need to find the points, right? The values of the functions. So now I cannot just take the values of the functions in order to find the probability. I need to find the area under this function, right? And it is really important, we discussed this last time, that the probability at the single point will be equal to the 0, right? So the probability that x, which is the continuous random variable, can take the specific value c will be equal. Technically, it is equal, so your interval is from c to the c, right? So that is why we need to integrate from c to the c, f of x dx. So then this is the antiderivative of the f at the point c minus antiderivative of the f at the point c, which is equal to the 0, okay? So technically, we say the probability that your professor comes exactly at 10 is equal to the 0. Okay? The probability that if I choose one of you, the height of you will be equal to the 180 is 0. Okay? So the probability of the continuous random variable when it takes a specific one value is equal to the 0. Okay? And we also say that we call the density, we call the function f as a proper density function if the total area under this function is equal to 1. Right? So today, we will discuss a couple of examples of the density functions. Then we'll learn how to calculate the expected value and the variance for the continuous case. Okay? So we will try to concentrate more on examples today rather than on new things because so probably a lot of people will miss the lectures this Saturday. So 3 groups are missing the lectures on Friday. And there will be makeup class on Saturday, so a lot of people will not come there. So I don't want that a lot of people will miss the news thing. Okay? So let's start with an example. Let's say x is the continuous random variable. With a density function which is given s. It takes the value just the x if the x is between 0 and 1. It takes the t minus x if x is between 1 and 2, and 0 otherwise. Okay? So our task, first of all, is to sketch the graph of the function. Second is check whether this is the density function. Check whether it is the density function. And 3 is we need to find the probability that x can take the value from between 0.5 and 1.5. Okay? So first of all, let us sketch this. So I need to put the rectangular graph, so the graph of this function in the rectangular coordinates, x, should take the values from 0 to the 1, one function, from 1 to the 2, another function, right? So how it looks like from 0 to the 1? It should be the simple x, right? So what is the value at the point 1? 1, right? Is it the horizontal line? No, right? This is the line like this, right? With the slope which is equal to the 1, okay? So what do you think, how the graph of the t minus x looks like? If you put x to be equal to the 1, what is the value of the t minus x? 1, right? If you put the t, what is the value of the t minus x? So if x is equal to the t, what is the t minus x? 0, right? In order to sketch any line, you just need to know 2 points, right? So we've got this point here and this point here. We need to just connect them, right? So the density function, do not like it. It is like it goes until to minus infinity there, but it takes the zeros, and it goes to the plus infinity there, but it always takes the zeros. Okay? So the density function looks like this. So now what we need to do is we need to check whether the area under this triangle is equal to the 1, right? We can easily do this geometrically, right? Do you remember how we need to do? We need to multiply the base to the height and divide this to the 2, right? So what is the height? 1. What is the width? 2, right? Divided to the 2 gives you 1, right? So the area is equal to the 1, so this is the proper density function. So is it possible to check it in a different way? We can check it by integrating this, right? So we need to integrate. So first task, solution to the second. So we know that the area of the triangle will be width multiplied to the height divided to the 2, which is 2 multiplied to the 1 divided to the 2, which is equal to the 1. Or in general case, if we don't know what is the formula finding the area of the triangle, but we know how to integrate the functions, we can integrate this, right? We can integrate from 0 to the 1. We need to integrate what function? Just the x, right? dx plus from 1 to the 2, what we need to integrate? 2 minus x dx, right? So hopefully you understand that for integration, we can split the regions, right? So you can write, for example, if you need to integrate from so if you need to integrate from 1 to the 2, so if you need to integrate from 1 to the 2, we can write this as the integration from 0 to the 1, and plus the integration from 1 to the 2. Why we can do this? From the idea of the integration, right? So the integration is the sum, so we can sum the first n terms, for example, separately, then the last n terms. Then we can sum them at the end, right? So this comes from the concept of the integration. So let us integrate this. So what will be the integration of the x? X squared over 2. Then we need to use the Newton-Leibniz formula and evaluate this, right? So 0, 1, plus what is the integration of the t minus x? It will be tx minus x squared over 2. We need to put the values t and 1, right? So let us evaluate this. It will be 1 over 2, right, minus 0 over 2, plus t multiplied to the 2 minus 4 over 2, minus t multiplied to the 1 minus 1 over 2, right? So we just need to sum everything together. So the first term is 1 over 2 plus 4 minus 2, what is this? 2 minus, so 2 minus 0.5 is 3 over 2, right? So 2.5 minus 1.5, which is equal to the 1, okay? So the second one is also checked. So we check that this is the proper density function, right? So if this is not equal to the 1, you cannot evaluate the probability using this function. Okay? So in the third problem, we need to evaluate the probability that x can take the values between 0.5 and 1.5, right? So what do you think? Is it different by writing this? This is the same in a continuous case, right? So this will be the integration of the density function in this interval, right? So again, we need to split this into the two regions, right? Because the density function is different in this region, right? Yes? So we need to find the probability here. So we need to find the area under this triangle from 1 over 2 until 3 over 2, right? So basically, I'm asking you, find me this area. This will be the probability of x in between 1 over 2 and 3 over 2, right? So obviously, we can do this geometrically, right? What is the idea? So we can find the area of the rectangle, right, and the triangle. Or we can just do the integration, which is like a not so easy most of the time, but this is like straightforward, right? So you don't need to know a lot of techniques, geometrical techniques, in order to do this. So let us write this. So from 1 over 2 until 1, it is one function, right? From 1 to the 1.5, this is different function, 2 minus x dx, right? So let's do this together again. So this will be x squared over 2. We need to put the values, 1 and 1 over 2, plus plus tx minus x squared over 2, so 3 over 2 and 1. So let's evaluate this. It will be 1 over 2 minus what? 1 over 8 plus, so 2 multiplied to the 3 over 2 is 3, right? Minus 9 over 4, 9 over 8, right? So minus, if I put the 1, it will be 2 multiplied to the 1 minus 1 over 2. It is 3 over 2, right? So let's evaluate everything together. So 1 over 2 minus 1 over 8 is, what is this? Is 3 over 8, right? 1 over 2 minus 1 over 8 is 3 over 8, plus, what is the 3 minus 9 over 8? 15 over 8 minus 3 over 2, right? Can I write this 3 over 2 as 12 over 8? Right? So then it will be 3 plus 15 minus 12 divided to the 8, which is equal to the 6 over 8, or 3 over 4. Okay? So it appears the probability that x can take the values between 0.5 and 1.5 is equal to the 3 over 4. And geometrically, I'm asking you, find me the area, this area, the area of this object. Okay? So this is what does it mean geometrically. So that is why sometimes the problems might be given like geometrically, and you need to figure out that you can do this using the integration or the probabilities. Do you remember last time we started this problem? Did you solve this? Okay. So the idea is the same. So first of all, we need to figure out what is the lambda. We can find the lambda by integrating this function from minus infinity to the plus infinity, right? So let's just evaluate the lambda for this example. So the density function is given as lambda multiplied to the e in the power of x over 100, right? If x can take the values from 0 until the infinity, and from minus infinity until 0, it takes the value 0, okay? Zero otherwise. x is more or equal to the 0. So in order to find the lambda, we need to integrate the density function from minus infinity to the plus infinity, or basically from 0 to the infinity. And equalize this to the 1, right? Because the total area under this curve should be equal to the 1, right? So what is the integration of this? It will be lambda multiplied to the e in the power of minus x divided to the 100, right? Multiplied to the minus 100, right? So we need to put here 0 and infinity. So how do we know this? That the antiderivative of this function is equal to this one? So you need to always understand that when we take the derivative, I'm asking the question, right? So the question is like this. So if f is like this, for example, sine of x, what's its derivative? This is when I ask you to find the derivative, okay? When I ask you to find the antiderivative of the integration, I'm giving you the answer. I'm saying, hey, f prime of x is equal to the cosine. What is the question? Okay, so you know what does it mean? The concept is like this. So when I ask you to find a derivative, it is like a lot of techniques which we can use in order to find the derivatives, right? A lot of rules, a lot of formulas. But when I ask you to find the antiderivative, then you need to think vice versa, right? You need to figure out the question so the answer is like this, right? So sometimes maybe you did this kind of stuff in the experiments, right? So you know the answer should be like this, right? Then you figure out the question, right? This is the similar thing here. So I'm given the answer here. So give me the function whose derivative is equal to this one, right? So you figure out the question so that the answer is like this, okay? So here, if I take the derivative, I need to use the chain rule, right? It will be e in the power of minus x over 100. Multiplied is the derivative of this term, which is minus 1 over 100. So there we will get the original function. So according to the Newton-Leibniz formula, this will be lambda multiplied to the e in the power of minus infinity, right? Multiplied to the minus 100, minus lambda multiplied to the e in the power of 0, minus 0 over 100, multiplied to the minus 100, right? So this term is equal to the 0. Then we will get 100 lambda, right? That's it. So this is equal to the 1. So that is why lambda is equal to the 1 over 100. So why this term is equal to the 0? Because this is like a e in the power of minus infinity means is 1 over e in the power of infinity, right? So 1 over infinity, which is equal to the 0. Okay. So once we've got the density function, then we can evaluate any probabilities. So do you remember we calculated the expected value in the discrete case by multiplying the outputs, its mass function, and summing them over, right? So the same idea for expected value here. Okay, so we calculate the expected value of the continuous random variable by integrating the multiplication of the x to its density function from minus infinity to the plus infinity. Very much the same idea. Okay, so do you remember we calculated the expected value in a discrete case by multiplying the function of the x multiplied to the same probability density function, right? Should I write this? Do you remember? So the expected value in a discrete case is equal to the sum of x multiplied to the p of x, right? And if you would like to calculate the expected value of the x squared, for example, or some function of the x, we needed to sum x squared and multiply this to the p of x, right? It comes from the physical meaning of the average, right? So the expected value in a continuous case, this is the integration of the x to the f of x. And expected value of the x squared, for example, this will be the integration of the x squared to the f of x. Okay, so very much like the same thing, right? So, but we're just taking into account that the integration is the same as the summation, but in a continuous case. Okay. Let's do an example. So before we start, let's try to define what is the uniform distribution in a continuous case, right? So what is a uniform distribution in a discrete case? Discrete, continuous. Right? So we say that, let's say, x takes the values 1, 2, 100, 500. If I say that the x has the uniform distribution in a discrete case, what are the probabilities? 1/4 always, right? They should be equal, right? What you need to do is you need to divide 1 to the number of the outputs, right? Because every output should have the same value, right? Now, let's discuss this in a continuous case. So, let's consider the random variable x, which takes the values only from 0 to the 1. Okay? So if I say that the density function of this random variable has the uniform distribution, so if I say that the x has the uniform distribution, how the density function should be? So it should be equally dense for all the regions, right, between 0 and 1, equally dense, right? So what should be the shape of the f of x? Just the horizontal line, right? Just the horizontal line. The only question is, where do I need to put this line? What is the height? So I need to put this at 1, because in this case, the area of the square will be equal to the 1, right? So if x has the uniform distribution, in between 0 and 1, then the density function of this x is equal to 1 in the interval between 0 and 1, and 0 otherwise. Right? So why this 1? Because the area under the curve should be equal to the 1, right? So this rectangle's area should be equal to the 1, right? So can we generalize the uniform distribution for more cases? For example, let's say you need to write a program in a computer, right? It gives you the values randomly between 1 and 100, right? Okay. Or let's say between 0 and 1. So in order to plug this in, you need to know its density function, or at least the mass function, okay? Then you plug this in. Now, let's say you would like to make the program which would generate us the random variables, not between 0 and 1, but between, for example, 3 and 4, or 1 and 5, okay? Or in general case, between A and B, okay? So let's say x has the uniform distribution in between A and B, okay? I would like to understand what is this density function. X. So in between A and B, it always takes the values between A and B with equal probabilities. What does it mean, right? So the points between 0 and 1, between A and B, are equally dense. So analogously, so there should be just a horizontal line, right? Yes? Okay. So I need to choose the height of this horizontal line, height, so that the area here of this rectangle should be equal to the 1, right? So what is the width of this rectangle? The width is equal to the b minus a, right? I need to multiply this to the height, and this should be equal to the 1, right? So what is the height then? 1 over b minus a, right? So here this is 1 over b minus a. So what will be, if I would like to write down this graph, this curve, this line, horizontal line, as the function. So f of x. So what should be this function? F of x is equal to 1 over b minus a, right? Always, because it doesn't change its value, right? It always equal to the b minus a in this region between a and b, right? So in general case, if I say that the x has the uniform distribution, then its density function is equal to 1 over b minus a, and x changes from a to the b, and 0 otherwise, okay? So in general case. And when we consider the case when x can take the value between 0 and 1, then the density function will be equal to simply 1, okay? Now, if it is clear, could you please calculate the expected value of the x if x has the uniform distribution between 0 and 1? Could you please calculate the expected value of the x when x takes the value, when x has a uniform distribution between 0 and 1? Okay, 1 over 2. So how did you know this? By integrating x to its density function, right? So if x has the uniform distribution, okay, do you remember how we wrote the notation of the distributions previously? For example, we say that x has the binomial distribution, right, where n is equal to the 10 and p is equal to the 0.7, right? The notation of what kind of distribution it has, right? It is faster than writing, hey, x has the binomial distribution, right? So uniform distribution, then what I need to give here, so density function here depends on the interval, right? So I need to give that x changes from 0 to the 1, okay? X has a uniform distribution between 0 and 1, so we need to find its expected value, x, which will be equal to the integration of from 0 to the 1, x multiplied to the f of x, which is 1, right? If you integrate this, it will be x squared over 2 from 0 to the 1. So this will be 1 over 2, right? Which is clear, right? If the x can take the values between 0 and 1 uniformly, right, then in average, it should take 1 over 2. Right? Okay. Oh, let's consider this case then. So let's say f of x is the density function of the continuous random variable x, which has this form. Could you please tell me what is the expected value of the x? You're too fast. So if x has the density function s, Tx, when x can take the values between 0 and 1, and 0 otherwise, right? Then the expected value of the x is equal to x multiplied to the Tx, right? From 0 to the 1. Then I need to integrate this. So this will be 2 over 3 multiplied to the x cubed from 0 to the 1. So this will be 2 over 3. Okay? The expected value is not just the integration of the f of x, right? So by the way, so we've learned this in calculus, right? So if I would like to find the average value of the function, what I need to do, average value of the function. So you're given a continuous function, right? If you would like to find its average value, what you need to do? Get the highest point and the lowest point. You need to integrate this function and divide this to the length of the interval. Okay? It gives you the average value of this function. Here, note that we're not finding the average value of the function, right? You're finding the average value of the output, not the output, of the input, of the x. Right? So in calculus, we've learned that if you're given the function, continuous function, its average is equal to the 1 over b minus a integration of this function in this interval. Okay? So basically, if you're given the function, continuous function in the interval between a and b, and if you would like to find its average value, so this will be like this. Okay? So you need to find the area and divide this to the length of this interval. It comes from the means value theorem. Okay? Here, we're doing this differently, right? So we're multiplying the f of x to the x and integrating this over this region. So it doesn't give us the average value of the density function, right? It gives us the average value of the x. Okay? What x I need to choose here? Okay? So analogously, what I need to do in order to calculate the variance then? If I would like to calculate the variance in a continuous case. So in a discrete case, so if I would like to calculate the variance of x, so by the definition, it was expectation of the x minus expectation of the x in the square, right? Or we wrote this as expectation of the x square minus the expected value of the x in the square, right? So in a continuous case, we had the same formulas, right? So in a continuous case, the variance of the x is equal to the expected value of the x minus e of x in the square, which is equal to the expected value of the x square we'll talk at the end, okay? Prepare your colas. Okay, for the previous example, could you please try to calculate the variance for this example, where f of x is equal to tx, right? And 0, so x can take the values between 0 and 1, and 0 otherwise. Okay? So previously we calculated the expected value of the x is equal to what? 2 over 3, right? 2 over 3. So then what is the variance? It is the expectation of the x minus 2 over 3 in the square, right? So according to the formula of the expectation of the function of the random variables, it is equal to the integration from minus infinity to the plus infinity of the x minus 2 over 3 in the square multiplied to the density function, right? So this density function is equal to tx in the region from 0 to the 1. We also can calculate the expectation, the variance, by calculating the expected value of the x squared minus the expected value of the x. Could you please do this like separately? So do the first and do the second. You need to get the same answer. So the integration from 0 to the 1, x squared multiplied to the tx dx minus 2 over 3 in the square. Probably the second is easier, but sometimes you need to know why the first one. Yeah. Okay, let's do this by the second way. It will be x squared multiplied to the tx is 2 over 4 x4, right? Yes? Excuse me, what? No. So by the formula of the expectation of the function, right? Do you remember? So in here. Where we wrote this? Here. So if you would like to calculate the expectation of the x, you need to multiply x to its mass function, right? If you would like to calculate the expectation of the x squared in a discrete case or in a continuous case, you need to multiply the function to the same density function. You don't change the density function at all, okay? In a discrete case, it is the same. In a continuous case, it is the same. Do you remember? We've got the same values from the table, same probabilities, right? So here is the same. So if you would like to calculate the expectation of the x squared, you need to multiply x squared now to the same density function, to the tx. Okay? So this will be 2 over 4 x squared from 0 to the 1 minus 4 over 9, so which is equal to 2 over 4 minus 4 over 9, which is equal to what? 1 over 2, 9, 1 over 9, 18? 18, right? So this will be 9 minus 8 over 18, 1 over 18. Okay? So if you calculate using this way, you need to get the same answer, 1 over 18. Okay? So I just wrote here this formula in order to understand that the expectation of the x minus 2 over 3 in a square is equal to the integration of the x minus 2 over 3 in a square multiplied to the tx. Okay? Now let us try to solve this problem. So let's say we've got a stick with the length 1. Okay? We split this at some point u. Okay? Okay? We split this at some point u randomly. Okay? So there is some point p, it is given. Okay? So some point p it is given, this is fixed. Okay? For example, this might be given like a 0.3 or 0.5. It doesn't matter. Okay? So you're given this stick with some marks at some point. Okay? Now you choose, you write your program, right? And you enter this, it gives you some value randomly between 0 and 1. Right? You take this value and cut the stick there. Okay? Always. Now, what is the expected length of the piece that contains this point P, that contains this mark? Do you understand the question? No? Okay. Again, you've got a stick. Okay? You put some mark here. For example, your mark is this. Okay? It should be 1 point. For example, this. Okay? This is your mark. Now, what you need to do is you randomly divide the stick into the two. Randomly means like at the random point. Okay? Which has the uniform distribution. It means that the chances it might be cut in any point are the same. Right? Okay, you cut this. Okay? Then you measure the length of the side, which has this mark. Okay? Now you do this experiment many, many times. Then you find the average of all the lengths, which has this mark, which has this point P. So I'm asking you, what is this average length?
Length from 0 to p, from 0 to p, from 0 to p.
The length of the stick. Okay, so for example, you've got the 1 meter stick, right? If you cut this at the point 0.7, and if the mark is here, what will be the length of the side which has this mark P? 0.7, right? So next time when you cut this at the 0.3, the length will be 0.3, right? And so on. If you do this many times and if you find the average length, what is the average length? But the problem here is that you don't know whether it's P. Okay, so P will be given. Your program should ask me P first, okay? Then it should calculate me average lengths. Okay, P might be here or there or there. So, but it is fixed. Okay, so this will be given. This is not random. The random here is the point where you cut the stick. Okay. Okay, let's solve this. Let's try to solve this. I don't know what is the solution, by the way. The example. Where's the stick, right? So let us first of all make the function of the L, okay? So L of u, this will be now the function which depends on u. U has the uniform distribution, right? It has the uniform distribution. between 0 and 1. What does it mean? It means that the density function of the u is equal to what? To the 1 if the u is between 0 and 1, right? Okay, now let us define the L of u, the length of the u, okay? So if you cut, so let's assume that P is here, okay? If you cut the u here, what will be the length of the, side which has this? 1 minus u, right? In which cases the length of the P's will be 1 minus u. Bigger than u, right? Okay, so this is equal to the 1 minus u. So this is equal to the 1 minus u, right? Do you understand this? You cut this at the u, so the length of the piece which has this point P is 1 minus u if u is less than P, right? Yes? If P is more than u. So in which case, the length of the piece which has this point P will be equal to the u. In the case if u is more than P, right? If u is more than P, then this is equal to the simply u, right? Okay. If u is more than P, this is equal to the u. Do you see this from the picture, right? For all the cases where u is less than P, right? The length of the piece which contains this point P is equal to the 1 minus u, right? Because if this is u, then the rest is 1 minus u, right? Because total length is 1. For all the cases when u is bigger than P, this is equal to the u. So the piece of the side, piece of the stick which has this point P is equal to the length which has a length which is equal to the u, right? Now, what we need to find? We need to find the expected length of the stick which has the P, right? We just need to find the expectation of the L of u, right? So in order to do this, what do I need to do? We need to integrate L of u multiplied to the f of u du, right? From minus infinity to the plus infinity. Do you remember this? So the expectation of some function of the random variable is equal to this function multiplied to the density function, to the same density function, and integrating this, right? Now, so let me put the values here. So u should be less than P, but more than 0, right? And here, u should be more than P, but less than 1, right? In order to make the intervals, okay? So I will split this into the two intervals. So from 0 to the P. From 0 to the P, what is the value of the L of u? 1 minus u. Multiply, what is the value of the f of u? 1, right? Multiply to the du. Plus, from P to the 1, this is equal to what? To the u, right? Du, okay? Then the rest is techniques, right? We just need to simply do the integration. The integration of this one is u minus u squared over 2. We need to put the values from 0 to the P. Plus the integration of this one is u squared over 2. We need to put the values 1 and P, right? So this will be equal to the P minus P squared over 2 plus 1 over 2 minus P squared over 2, right? So the answer will be 1 over 2 plus P minus P squared. Right? I think this is like this. So 1 over 2 plus P, it will be 1 minus P. Okay, let us check the solution. Oh, we got this correct solution. Good. Do you understand what we did? Yes? So when you think in the first glance, it was really difficult, right? Then we understand that we need to find the expectation of the L. Then we build, first of all, the function of the L. Then we found out the expectation of this L. Okay? So this comes from the experience. So we need to do a lot of exercises. And hopefully we will figure out what is FU. This is from the definition of the U. Right? So we say that, hey, if U has takes the values uniformly between 0 and 1, then its density function should be equal to the 1, right? Because the total area under this curve should be equal to the 1, right? So we defined the uniform distribution previously. So if x has the uniform distribution between a and b, then its density function is 1 over b minus a, right? Okay. Let's do a couple of examples. So we will do one example which is like a, let's do this. Example of the conditional probability in a continuous case. Conditional probability. So previously we calculated the conditional probability when we had examples, right? Hey, like if you toss the coin, if you got like a, I don't know. So if you roll 2 dice, what is the probability the sum is equal to the 6 if the first one is 2, right? This kind of examples. So let us try to evaluate this kind of example. So let's say x has the uniform distribution between -2 and 3. Okay? Could you please evaluate probability that x is more than 2 if it is given that x is more than 1? Probability that x is more than 2 if it is given that x is more than 1. So what we need to do is we need to use again the Bayes theorem, right? Or we can simply use the this version of the Bayes theorem. So this is equal to the probability that x is more than 2 and, right, do you remember? X is more than 1 divided to the probability what? X is more than 1. Do you remember the formula? So probability of B given A is equal to the probability of B and A divided to the probability of A, right? Or we can write this as the probability of A given B multiplied to the probability of the B divided to the probability of the A, right? Because probability of the B and A is equal to this one, right? So what is the probability that B happens and A happens, right? This is the probability of the B happening multiplied to the probability of A happens when the B is already happened, right? So this is the formula of the Bayes rule. This is also the formula of the Bayes, okay? So we work always with this formula, but there is this version which is the equivalent, okay? So in order to calculate the probability that x is more than 2 if it is given that x is more than 1 already, we need to use this version, right? So we calculate what is the probability that x is more than 2 and x is more than 1, right? Divided to the probability x is more than 1. So let us evaluate first of all probability that, let us first of all construct the density function, right? If x has the uniform distribution, what will be its density function? It will be 1 over 5, right? 1 divided to the b minus a. So b is equal to the 3, a is equal to the minus 2, right? 1 over 5. If x takes the values from minus 2 to the 3 and 0 otherwise, right? So what will be the probability that x is more than 1? This is the integration, right? From 1 to the infinity, but since the density function is 0 after the 3, I can simply put here 3, right? Of the f of x dx. So from 1 to the 3, what I need to put here? 1 over 5 dx. So this will be equal to the 1 over 5 multiplied to the x from 1 to the 3. So this will be equal to the 2 multiplied to the 1 over 5. Right? So the probability that x is more than 1 is equal to 2 over 5. So now, could you please tell me, what is the probability of the intersection of the sets? So x should be more than 1, and x should be more than 2. What I need to find? What I need to find? I need to evaluate the probability that x is more than 2 only, right? So probability that x is more than 2 and x is more than 1 is equal to the probability that x is more than 2 only, right? Do you understand this why? Because here, and means you need to find the intersection. So first of all, find the intersection of the set, right? Then find its probability, right? Intersection of the sets will be all the points which are more than 2, right? Intersection. It means like a point which has in both of the sets, right? Do you understand this? So x is more than 2 is all the points there. X is more than 1 is all the points there. Do you remember how we did this in school, right? So we did this like this. Then we said, okay, so the x is more than 2, then like this, right? Then x is more than 2 is the intersection of the x is more than 2 and x is more than 1, right? Okay. So this will be 1, the integration from 2 until what? Another? Until 4? Until 3, okay. Of the 1 over 5 dx, so this will be just simply 1 over 5, right? Because if you integrate this, it will be 1 over 5x. If you substitute the values from 3 to the 2, it will be 1 over 5. Now, the conditional probability of x is more than 2, if it is given that x is more than 1, is equal to probability that x is more than 2 divided to the probability of x is more than 1. So this will be equal to the 1 over 5 divided to the 2 over 5, which will be equal to the 1 over 2. Okay? So this is the conditional probability from the different perspective, right? Okay. So let us do one more example about the cumulative distribution, okay? Example on cumulative distribution. Do you remember what we call as a cumulative distribution function? So previously. So we say that the probability, if the mass function is given as p of x, right? Then cumulative distribution function p of x is equal to the probability that p of y, let's say, or f of y, is equal to x is less or equal to the y, right? So you need to sum all the values until the y, right? For example, if x starts from the 0, so this will be x is equal to the 0 plus 1 plus all the values until the y, right? So now in a continuous case, if I say, hey, what is the cumulative distribution function of at the point y, what we need to do? We need to integrate our density function, right? From where to where? From minus infinity until the y, okay? So sometimes you might see this in this form. So f of x will be equal to the integration from minus infinity to the x. So what I need to write here? F of t or f of y dt, right? So differently, right? Because do you remember, so if you would like to eliminate the variable, you need to integrate this. If you would like to eliminate one of the variables from your function, you need to integrate this. After the integration, there will be no variable. This will be the constant, okay? Unless you don't have the variables on the integration, right? Do you remember the fundamental theorem of calculus 1? Yes? What does it tell you? So it is important for our later lectures. What does the fundamental theorem of calculus 1 tells you? So it tells us that if my function g of x is given as the integration of another function until the x, then derivative of this function g is simply this function f, but with respect to the x, right? So later on we will try to do this. So later on we will see that if I'm given the density function, I can find the cumulative function by integrating this. But sometimes if I'm given the cumulative function, we can also find the density function by just taking the derivative from the cumulative function. Okay? So do you understand what does it mean, this thing? Right? So just a small example. For example, let's assume that g of x is equal to the integration from 0 to the x of the sine of t dt. Okay? What does the theorem tell you? theorem tells you that if you integrate this, then take the derivative. Derivative of the g will be equal to the sine. Okay? What does it tell you? This is what does it tell you. Okay? So we can check it, right? So what will be the integration of the sine? Is minus cosine of t, right? We need to put from 0 to the x. If you put the x, it will be minus cosine of x, right? If you put the 0, it will be plus 1, right? Now, if you take the derivative from 1 minus cosine of x, what you will get? Simply sine of x, right? The theorem tells you this. It tells you that if you have the function where this x is on the border of the integration, then whenever you take the derivative, you don't need to integrate and take the derivative. Just take this function under the integration as the derivative. Okay? So, or similarly, do you remember the connection between the speed and the velocity? Yes? So if you're given the distance which you need to pass, or distance which you're passing in some point t, for example, let's assume that you passed like 20 kilometers and between 0 and 1, so your displacement basically, okay, like this. So if you would like to find the velocity, you need to find the derivative, right? So the slope of the tangent line at a single point x gives you velocity. Slope is equal to the velocity. Okay? At the same time, if you're given the function of the velocity, you can find the distance, right? For example, let's say your distance is always the same, okay? Always is equal to the 60, right? So after 1 hour, it was 60. After 2 hours, it's also 60. If I ask you, hey, how much distance you passed from 0 time until 2, how much distance you will pass? This will be the area here, right? So if you drive always with the constant velocity, 60 kilometers per hour, how much distance you will pass in 2 hours? 120, right? Which is the area under this curve, right? Okay, now the question about the fundamental theorem of calculus is like this. So let me give some x, okay? So if you're given the function of the velocity, so if your program asks me the x, it will tell me how much distance your car will drive until the x. Okay? So let's say you wrote a program. If you type the x, it tells me what is the distance you passed until the x time. Okay? Now, if I ask from your program, not what is the distance, but what is the velocity at the point x. So I give you, hey, x is equal to the t. What is the velocity? This is what I'm asking. You don't need to integrate this, then take a derivative, right? You don't need to integrate this by finding this and take the derivative by finding this, right? The velocity will be here, 60, right? So this is what does the fundamental theorem of calculus 2 tells you, okay? So it is important to know because later on we're going to use this, okay? So sometimes we'll be given a cumulative function and we need to figure out what is the density function, okay? Now we know how to get this, right? If you take the derivative from the cumulative function, we will get the density function, okay? Okay, still we need to do an example, right? Okay, let's do our classical example. So if f of x is equal to the tx, where x in between 0 and 1, and 0 otherwise, could you please find the cumulative distribution function for the same x? So this will be integration from 0 to the x of ty or tt. You need to call this differently, right? You cannot call this x. So tt dt, right? So this will be t squared over 2 from 0 until the x, right? Then this is equal to the x squared over 2. Okay? The cumulative distribution function is equal to the x squared over 2. What? Oh, okay. Sorry. Just a t squared. What about the uniform distribution? So let's talk about this. So if X has the uniform distribution between A and B, then its density function is equal to 1 divided to the B minus A, right? If X in between A and B, and 0 otherwise, right? Now let us try to figure out geometrically what does it mean, okay? The cumulative distribution function. So I will draw from A to the B. This should be the line, right? So the cumulative distribution means that I need to choose one point X in the X line, right? And it should tell me the area until this point, right? Until this point. It should tell me the area until this point. All the area from here and this one, okay? So what is the area if I choose the X before the A? 0, right? The area will be 0 if X is less than A. What is the area if I choose the point X between the A and B? What will be this area? So this is 1 over B minus A, which is the height of the rectangle, right? Multiplied to the width. What is the width? X minus A, right? X minus A. Do you understand this, right? For example, I choose this rectangle. What is the area of this rectangle, which is marked with the blue? So this is the width, which is X minus A, multiplied to the height, which is B minus A, right? 1 over B minus A, right? Do you understand this? Yes? Okay. And if X is more than B, what is this? Simply 1, right? So this is the cumulative distribution function of the X, which has the uniform distribution between 0 and 1, okay? If you take the derivative from this with respect to the X, you will have the same thing, okay? You will have 1 over B minus A, okay? So this was about some exercising and some lecture about the continuous distributions. Do you have any questions? Okay.